Hello, everyone. Today, we are going to learn 2.6 quadric surface. So quadric surface, we have, I made it here, ellipsoid here, ellipsoid, and paraboloid. I practice pronunciation, hyperboloid. So we have more than those kind of the figure. So let's do it. Previously, we have equation of a sphere. Okay, let me let me come back. Okay, so I brought the equations here. So equation of a sphere, we did that. That one. And equation of a circle, we have that, right? In that case, the center at x naught and y naught, right? And then we have a unit equation of a unit circle means that the radius equal to 1, right? So we have x squared plus y squared equal to 1. And we have an equation of a plane. We just did the last section. So we have that equation, right? And then from there, we can make general form, right? So let me write down this one. Just forget it. Okay, how about this? Cylindrical surface. So we learned from the Calculus 2 cylindrical shell, right? So any curve can make cylinder, right? So we have a cylindrical surface. Any curve can create cylinder. So surface, this is a 3-dimension, right? And like a title, as this section, we have a quadric surfaces. So quadric surface. Let me bring. So we have a quadric surfaces. So form of equation crazy like this. But then we learned ellipsoid, elliptic, paraboloid, ellipse, circle, hyperbola, parabola, and so on. Okay? So let's do cylindrical surface first. Cylindrical surface. Okay, so we have an example. We have x squared plus y squared equal to 9. In 3-dimension, I'm sorry, in 2-dimension, this is a circle and radius equal to 3, right? Because we have r squared, right? So in 2D, this is a circle, r equal to 3, right? Okay. Now, this is a surface. Surface means this is a 3-dimension, right? Okay, then how do we draw the graph cylindrical surface, right? Okay, so in 3D, it's a cylinder. And there is a missing variable, which is z, right? So cylinder, we said opens the z-axis. z-axis. So think the missing variable z in the equation. Yeah. All right. So open sum means it's parallel to so basically parallel to z x-axis. Okay, so I'm gonna draw the roughly x squared plus y squared equal to 9 as a cylindrical surface. So z-axis, x-axis, y-axis, right? Okay, so cylinder opens parallel to the z-axis, so like this. I'm not going there. Yeah, and then parallel to, so like this. Okay, and then also we say that parallel to z-axis, so this is ruling. Okay, let me write down the definition of ruling. Okay, so they say that a set of lines parallel to a given line passing through a given curve is a cylindrical surface, cylinder in 3 dimensions. The parallel lines are called ruling. Okay, so that's the terminology we have. All right, let's draw x cube. So in 2 dimensions, how do you draw x cube? Y equal to x cube, right? Then 2 dimensions. So this is a y-axis, this is x-axis. So we draw like that, right? Okay, how about z equal to x cube? So if we want to draw with the x and z, this is x, this is z. Yeah, can you see that? Pointing. Y equal to x cube, z equal to x cube. Z is acting like a y, right? Same as then, right? So we draw like this, x cube, right? All right. Then how do we draw z equal to x cube in the 3 dimension, right? So number 2, example. So z equal to x cube. So this is z, this is x, this is y, right? Okay, let's analyzing. In that case, x is positive. This one, start x is positive. Also z is positive, right? Then in 3 dimension, which part is x is positive and y, I'm sorry, not y, z is positive, right? So this part is x is positive, y is positive, right? So we draw like this. Yeah. We draw. No. Yeah. So bad. Okay, last chance. This is looks like that. Say just uh-huh. All right. So I have a decimals here. I'm gonna show you. All right. So z equal to x cubed decimals in 3 dimension, right? So it looks like that. So g, and this is x-axis, this is y-axis, yeah? So you guys can see that like this. Wait, should I stop here so that you can see better, right? Okay. Okay, so I insert a screenshot here. Let's do example number 3. We have x squared plus z squared equal to 25, which is the cylindrical surface, right? All right, then what is the missing variable, which is y, right? Then that ruling is parallel to y-axis. So think pencil, y-axis. Missing variable. Ruling parallel to y-axis. Okay, so we have z-axis, x-axis, y-axis, right? Okay, so we can make that the radius equal to 5, right? Equal to 5. Okay, so I'm gonna make just approximately the radius equal to 5. Let's just open the okay, so I draw this way, and then ruling parallel to the y-axis. Yeah. Okay. So I have a picture, better picture, because I'm not in the drawing. Look, x squared plus z squared equal to 25. Very nice, yeah? Okay, let me make a screenshot. Okay, so screenshot. attached here. How about, let's just do the sine x. That's the example 4. Y equal to sine x. Yeah. All right, so we knew that in 2D, sine starts at 0 and then the periodic function, right? Okay, so let me show you decimals in 3 dimension. So let's take a look. Yeah, it's like that, right? 2 dimension. Okay, what if we extend the 3 dimension? Y equal to sine x. So missing variable, which is z. So open sub z-axis. Can you see that? Ruling parallel to the z-axis, right? Yeah. Can you see that? And then the curve, periodic curve is like this. So let me little bit, it's looks better this way to you? Ooh. Okay, so right hand rule. So Z, where's Z? Oh, this is Y. This is X. This is Z, and then this is X. Okay. So we should get this way, right? Yeah. So let me screenshot. Okay, now we have a terminology, the traces. The traces of a surface face are the cross-sections created when the surface intersect a plane parallel to one of the coordinate planes. So we have XY traces, YZ traces, and XZ traces. Yeah. Uh, Let me give it to you. Think easily. So think XY traces. Think XY plane. So when you talk about the plane, what's the xy plane of the equation? Equation of xy plane, right? So we had z equal to 0. What about the yz traces? So think yz plane. Then what's the equation of that? That's a missing variable is x, so x equal to 0, right? Now xz traces. Think XZ plane, the missing variable, which is y, so y equal to 0, right? So we are using those traces. So think xy plane, set z equal to 0, yz plane, set x equal to 0, xz plane, set y equal to 0. Okay, let's do quadric surface. So we talked earlier, right? Let me bring back quadric surface. So we have ellipsoid, elliptic, paraboloid, ellipsis, circle, hyperbola, parabola, etc. Right? Okay, copy. Okay, ellipsoid. Let's talk about the ellipsoid. So we have ellipsoid. Soid. Okay, every plane is ellipse. Every plane is ellipse. So the figure of ellipse looks like that, right? Looks like this. That's the ellipse figure. All right. So every plane, so we have XY plane, YZ plane, XZ plane, right? So let me copy this one. Okay. Make it shrink. Oh, please. Okay, good. All right. The equation of an ellipsoid is we have x squared over a squared plus y squared over b squared plus z squared over c squared equal to 1. Okay, so let's show that every plane is an ellipse. So let's make a xy plane. So we set up xy plane, then z equal to 0, right? All right. So if z equal to 0, then we get only this, right? Then this is the equation of ellipse. So let's see. X squared. So we have x squared over a squared plus y squared over b squared, which is 1, right? So this is ellipse. So this is a 2D, right? So 2D we called ellipse, three-dimensional ellipsoid. Okay, now YZ plane, then we set x equal to 0. Then we set x equal to 0, then this is that, right? So that will be y squared over b squared plus g squared over c squared equal to 1. Also, we called this one is ellipse. Okay, xz plane. Set y is missing, so y equal to 0. Then this is 0, then we have this, right? So that will be x squared over a squared plus z squared over c squared equal to 1. This is also ellipse. Okay. So let's take example so we understand the ellipsoid, right? Sketch the ellipsoid. Sketch the ellipsoid. So we have x squared over 2 squared plus y squared over 3 squared plus z squared over 5 squared equal to 1. This is the equation of ellipsoid. Okay. The first one, xy plane. Let's follow that, right? XY trace. So same as XY plane. Then we set z equal to 0, right? Then this is 0. And we get this. So that would be x squared over 2 squared plus y squared over 3 squared equal to 1. That is the ellipse we talked earlier, right? So that would be this is x, this is y. Okay, so this 2 will be, 2 square will be x-axis, right? So negative 2 here, positive 2. So we call fussy. Correction. Foci. Oh my gosh. Not the fussy. Foci. So focus. Foci. Okay. So 2 and negative 2. And then y-axis 3 and negative 3, right? Okay. So we connect. So there will be, I'm not good. So let me try. So the idea is like that. Ellipse. Ooh, see? Ooh, I did not breathe. Okay. Oh, I think there is a nice feature. Let me try. Uh, okay, see? Yeah, I should use technology. Okay. All right, so why z trace? So yz plane, set x equal to 0. Okay, then this is 0. We get that. So we have y squared over 3 squared plus z squared over 5 squared equal to 1, right? So ellipse. So that will be, how to draw? Y there, z there. Okay, y equal to 3, negative 3, positive 3, and so I want to make a positive 5, negative 5, okay. Just a leave, yeah? All right. How about xz? Xz trace, xz plane, set y equal to 0. So y equal to 0, then we have that. So x squared over 2, x squared over 2 squared plus z squared over 5 squared equal to 1. So ellipse. Okay, so this is x. This is z. So negative 2, positive 2, and positive 5, negative 5. Ooh. Ooh. Okay, just leave. Okay. All right. All together. Let's draw ellipsoid. Yeah. Whew. I try to best. So this is Z. This is X. This is Y. We have XY plane. So X equal to 2, right? So 1, 2, and 1, 2, negative 2. And then Y equal to 3, right? So so 1, 2, 3. 1, 2, 3. Ooh. I want to make a street. Yeah. 1, 2, 3. Yes, 2, huh? Okay. So let's connect. This is a 3 dimension, so looks like a 3 dimension, right? Yeah. But then we know the shape is a ellipse, right? Okay. How about YZ trace, YZ plane? Y3, so 3, and Z. 1, 2, 3, 4, 5. How about that? And oh, 1, 2, 3, 4, 5. Okay, so like a 3 dimension, right? Yeah, ellipse. Okay, the last one, XZ trace. 2. Oh, no, sorry. 2, 2, 5, 5. So this is a little bit easier. Yeah. Yeah, I made it. So ellipsoid. Yeah, I'm gonna show you a better picture here. That's moss. Da-da-da. Beautiful picture, right? So let me make a stop. Dot. Stop, right? Right hand rule. Z, X, Y. Yeah. Screenshot. Okay, so we have one of quadric surface. Uh, uh, the elliptic paraboloid. Crazy. Elliptic paraboloid. So we just want the ellipsoid right now, right? And then second one, elliptic paraboloid. So let's take a look. We have three types here. So we have the equation of elliptic paraboloid, x squared over a squared plus y squared over b squared equal to z over c. So a squared b squared c is the just number, right? And then we can see that z has only degree 1. Can you see that? X squared, y squared, and then z, not the z squared. So we say that this is open z-axis. And then they say that the trace in an xy plane ellipse, but xz plane and yz plane are parabolas. Parabolas. Yeah. So this is the figure of elliptic paraboloid. Let's take a look. Yeah. So this is that. So type 2, we have x squared over a squared plus z squared over c squared equal to y over b. Then that means open y-axis because the y has degree 1. And type 3, we have y squared b squared plus z squared over c squared equal to x over a. And then opens x-axis because x has a degree 1, right? So let me write down here. Okay, so I wrote down everything, type 2, type 3. So since elliptic paraboloid looks like that, so let me draw here too, approximately. So z, x, y, open y-axis. So let me make like that, right? And then parabola everywhere, right? I mean the XY plane, YZ plane. So just follow that. Okay, how about here? So yeah. Z-axis, x-axis, y-axis, open x-axis. So looks like that. And then parabola. It's hard to make a parabola in 3D. And XY plane, XY plane. Parabola like this. No. Forget it. So I just want to write down, draw like that. Okay. Let's do example. Describe the trace of the elliptic paraboloid. Describe the trace of the elliptic paraboloid. X squared plus y squared over 2 squared equal to z over 5, right? Okay, so we have to recognize what kind of equation of this. So they said already elliptic paraboloid, right? Because we have to have x squared over a squared, in that case 1 squared, right? We don't see the number, that means 1, invisible 1. And then we have a plus y squared over z, not z, it's 2 squared, right? Equal to z over 5. So this is an elliptic paraboloid, open z-axis, right? Because z has degree 1. Open z-axis since z has degree 1. Okay, so let's analyzing the trace for xy trace. So we think xy plane, then set z equal to 0, right? Then this is 0. So we have x squared plus y squared over 2 squared equal to 0, right? We don't know anything about this one. X squared plus y squared over 2 squared equal to 0. So don't know. The shape of the geometry or figure. Okay, then let's set up anything, whatever convenience for you. Let's follow z equal to 5. Okay, then we have x squared plus y squared over 2 squared equal to 5 over 5, which is 1, right? Okay, what we can see that x squared plus y squared over 2 squared, which is 1. Oh, very good. Ellipse, right? So this is ellipse. We just did that earlier. Good job. Okay, let's do for xy trace, xz trace. So that's xz plane, then let's set up y equal to 0, then y equal to 0. That will be 0, right? So x squared equal to z over 5. X squared equal to z over 5. All right. Then solve for x. I'm sorry, solve for z. Then we have a z equal to 5x squared. This is a parabola, right? So that would be zx. Looks like this. Okay, yz trace. So this is the yz plane. Think set missing x equal to 0. Then we have x equal to 0. That will be 0. Then we have this. Yeah. So we have y squared over 2 squared equal to 5 over, z over 5, right? Okay. Then solve for z. So that would be that's the 5y squared equal to 4z, right? Then we have z equal to 5y squared over 4 then. Yeah. also, oh, parabola, right? So there will be, this is Z, this is Y, so parabola as well. Parabola. Okay, so let me bring all the quadratic surfaces from the textbook. Okay, so here is quadratic surfaces, elliptic cone, elliptic paraboloid. We did that earlier, right? And hyperbolic paraboloid and ellipsoid, we did that earlier, and hyperboloid of one sheet and hyperboloid of two sheets. Yeah. But in those shape, there is a type, right? It depends on. So let's talk about that. Um, let's do in order. Elliptic cone. So the equation looks like this. Other side is 0. That means we can move the negative part, which is in the case is z, right? Can you see that? It's a positive, this is negative. We add z squared over a squared. Then we get uh, x squared over a squared plus y squared over b squared equal to z squared over c squared, right? So if we see this kind of equation, also we can notice that this is an elliptic cone. Yeah, the shape looks like this. And then look, the axis of a surface corresponds to the variable with negative coefficient. So in that case, the z has negative, right? That means open z-axis. Open z-axis means the shape looks like that. This is open z-axis. Can you see that? Okay, now elliptic paraboloid, we did that earlier, right? Okay, we can just have no coefficient, I mean, no number, no, what is called? No denominator, right? It can be no denominator, no denominator, so it can be anything because we had no denominator x squared earlier, right? So x squared, a squared plus y squared b squared minus z equal to 0. It can be, right? Yeah. If we see this kind of form, we might think elliptic paraboloid. Make sense? And then they say that surface corresponds linear variable. In that case, linear variable has degree 1, right? So means degree 1. Degree 1. So in that case, z has degree 1. So open z-axis. Yeah. We went over y over c, x over c earlier, right? There is two types. I'm sorry, three types. So everything has three types. Yeah. The first one, elliptic cone. So they corresponding with a negative coefficient. If a negative coefficient in x squared, then open x-axis, right? So looks like this. Yeah, looks like paraboloid. Yeah, I have to make a little bit. Yeah. Oh, so bad with it, right? Okay. Third one, hyperbolic paraboloid. Let's take a look. The surface corresponds to the linear variable. In that case, it's z, right? So the shape is looks like that. So open z-axis. Yeah. What else we can say that? We can say that y over c, right? Or y. And then the equation looks like this. X squared minus y squared. It could be x squared minus z squared equal to y, right? Yeah. Make sense? I don't have to write down everything, right? Type 1, 2, 3, right? Yeah. But it could be the equation looks like this, or move everything up the one side so we can have x squared over a squared minus y squared over b squared minus z equal to 0, all right? Or it can be z over c. Yeah. Okay. Now, almost done. Ellipsoid. We did earlier, right? Ellipsoid. They said that if A equal to B equal to C, then surface is a sphere. You know why, right? So let me give it to you like that. We have x squared over 5 squared plus y squared over 5 squared plus z squared over 5 squared equal to 1, right? Then we multiply by 25 each term. Then we get x squared plus y squared plus z squared equal to 25. Yeah. Then this is a sphere, right? And center at the origin are equal to 5, right? So if A equal to B equal to C, then it's a sphere. Can you see that? Yeah. All right. So we have hyperboloid over one sheet. So the equation looks like that. X squared over a squared plus y squared over b squared minus z squared over c squared equal to 1. Okay. Then they say that surface corresponds to the variable with negative coefficient. So in that case, negative coefficient is z, right? Let me see this. Open z-axis. That's why the shape open this way, right? If we have a negative on the x-axis, then looks like this. Not good. Yeah. All right. And if we have a negative on y-axis, then uh, like this. Yeah. Okay. So I don't have to write down, right? So we knew that. So every quadric surface has three types. Yeah. X or Y or Z, right? Okay. Very good. Um, so we had earlier ellipsoid xy plane, xy trace, z equal to 0, right? So same as here, xz plane, y equal to 0, yz plane, x equal to 0. Then same as here, this means z equal to some number, xy plane, xy trace, and y equal to some number. So that means xz plane, xz trace, and x equal to some number, then that will be yz plane, right? Yeah. Okay. The last one, uh, this is a hyperboloid of two sheets. So they separate, right? Okay, so we have a surface corresponds to the variable with a positive coefficient. So the equation looks like this. Where is positive? The g has positive in the case, right? So open z-axis. So we have, looks like that. Open z-axis, yeah? If we have x is positive, then the shape like this, right? Yeah. And if y is positive, then the shape like that, right? So everything is okay? All right, then we have the two more questions, then we're done for this section. Uh, let's do it. Identifying equation of missing a quadric surfaces. Okay, so we have 16x squared plus 9y squared plus 16z squared equal to 144. Can you think about that? Okay, I'm gonna show you everything here. Okay, so every side has 0, or 1, right? Then we want to make 1 there, right? Other side. Take, make 0 or 1 for other side. Okay, in that case, we divide by 144 every term. Can you please calculate? So we have x squared over 9 over, I'm sorry, plus y squared over 16 plus z squared over 9 equal to 1. Okay, what do you get from here? Very good. Ellipsoid, right? So this is the, this is the one equation, right? So ellipsoid. Which color? Okay, I have another question. That will be the last one for this section. You need to do that. Okay, so here is the last questions. Take a look. So a elliptic cone on y-axis means opens up y-axis, ellipsoid and hyperboloid of two sheets. And then elliptic D as dog. Okay, elliptic cone on z-axis means opens up z-axis, right? Elliptic paraboloid on y-axis. Yeah. Okay, let's do the first one first, right? So we can express this one. X squared over 2 squared plus y squared over, oh no, it's a 4 squared, not the 2 squared. 4 squared, 5 squared minus z squared over 9 squared equal to 0, right? And what is that? So take a look. So can you see that this is the form, right? This is the form x squared over a squared plus z squared, I'm sorry, y squared, and so on, right? And then this is the corresponding, oh, why moving? Corresponding the negative coefficient. So in that case, opens up z-axis, right? So elliptic cone on opens up z-axis. So that is the one, right? D is the so this is D. And then second one, it's very similar with the first one, isn't it? Yeah. But then negative coefficient is corresponding to y, right? So elliptic cone, y-axis. Yeah, it's easily to find. And the third one, oh, this is a little bit straightforward, right? This ellipsoid, what we did, right? So everything is positive and then squared, x squared over a squared plus b squared, I'm sorry, y squared over b squared plus z squared over c squared equal to 1. That's the ellipsoid, the equation of ellipsoid, right? Okay. This one, something we did earlier, right? Elliptical paraboloid, right? In that case, the what is called corresponding negative. That means opens y-axis. So elliptic paraboloid on y-axis, right? So this one. So E. Okay, then what's missing? Hyperboloid of two sheets. Okay, let's take a look because a little bit new, right? Hyperboloid of two sheets. Let's take a look. Everything is negative except the positive. So this is basically opens x-axis then, right? Because look, this one is a negative on z-axis. That's why opens the z-axis, right? This one negative on y-axis opens y-axis, right? But in that case, two negative, then it must be opens up x-axis. We're looking at the positive things, right? So let's take a look. Hyperboloid of two sheets. Hyperboloid of two sheets. So there you go, right? Yeah, it's a positive on z. So opens up z-axis, yeah? And then the form of the hyperboloid of two sheets looks like that, right? Okay, so bingo. So we have this is a C. The A, B, E, C. Yeah. All right. This one also we can express x squared over 4 squared plus z squared over 9 equal to y over 5, right? Okay. Any question? Thank you very much for watching. I will see you in next section 2.7. Thank you. Bye-bye.